Hello everyone, and welcome to Say It with Symbols, Investigation 4 that we get kicking off here today. Our learning target for Investigation 4 is that we'll be able to solve problems, both linear and quadratic, set in real-life situations. And we want to be able to write an equation given 2 points if the relationship is linear, quadratic, or exponential. Our ACES questions for 4.1, lots of them. All of 1 and 56 here for 4.1. Looking back at functions, it says throughout your work in algebra you've identified patterns of change between variables as linear, exponential, and quadratic functions. We've used tables, graphs, and equations to represent and reason about these functions. Now in this unit we've found that writing equivalent expressions for a quantity or variable can reveal new information about that situation. We're hoping that this investigation will help pull these ideas together. So we're going to visit back to a problem we did when we were linear. I think it was thinking with mathematical models of pumping water and looking at patterns of change. It says Magnolia Middle School needs to empty their pool for resealing. Ms. Theodora's math class decides to collect data on the amount of water in the pool and the time it takes to empty it. Well, the class goes ahead and they come up with this equation, and it says W for water in gallons and T for how many hours the pool has been draining. And then it asks you some questions. What does the negative 250 represent? What units should you use for the negative 250? What information does a T minus 5 represent? And what units should we use for that? And for the whole thing, what unit should we use for negative 250 times T minus 5. So as with all equations or expressions that you're given, you should look at each and every part and try to determine what it represents and what units you want to use. So think about this. If we have water, that's represented in gallons here, and time in hours, what do these other two numbers represent with all of this? Remember, we have a pool that has water in it, and we're trying to drain that pool, and we want to know how long it takes. So what does every part of this represent? So I need you to stop, think about that, pause the video if you need to, and come up with your explanation for all of the things listed here. Then we look at A, B, and C here. It says answer the following questions and explain your reasoning. They gave you an equation, and now you need to determine how many gallons of water are pumped out each hour. How long will it take to empty the pool, and how many gallons of water were in the pool to start with? There's a way of deducing all of that information from this equation that we're given here. And it might be easier for you also if you look at B and it asks you to write an expression for the amount of water in the tank after T hours that is equivalent to the original expression. Well, I went ahead and put the original expression back in right here. What's another way that we could write this? What's another expression that we could make from this that is equivalent to the original expression but might be easier to read? Okay, and it says here, what information does this new expression tell you about the amount of water in the tank? And which is more useful in this situation, the original one or the new one you come up with here for B1? Be thinking about some of the properties and systems and things that we've been using so far in this book and the practices that we've gone through and done. Hopefully that will expand your mind. That might have been punny, so you might want to go back and try that again. And C, describe the pattern of change in the relationship between the two variables W and T, and then without graphing the equation, describe the shape of the graph. Okay, so you should be able to look at the form that we have here and determine whether it's linear, quadratic, exponential, that sort of thing, and be able to describe to us what the graph would look like in the shape of it. Finally, in D, how many gallons of water are pumped out each hour if we change the equation to W equals negative 450 times 2T minus 7. Then Your two questions, 1 and 56. Good luck.